Hello students, my name is Nishad Naik and today we are going to discuss units and measurement. So what is unit? Unit is the standard measure of any quantity. Unit is standard measure of physical quantity. For example, we will take a physical quantity as mass. What is unit of mass? Kg. Right, so kg is the unit and mass is physical quantity. Now second example I will take of force. The unit of force is Newton. So this is unit and this is physical quantity. Okay, this is physical quantity, this is unit. So if I write one example like 10 Newton, 10 N, then this is the value, but this is called as unit. This is unit. Or I will write 2 kg, so kg is unit. 3 meter, so meter is unit. Okay, so this is the unit. Kg, meter, Newton, all are units. And physical quantities means like mass, force or acceleration, velocity, all that are physical quantities, and respective kilogram, Newton, gram, all that are units. Now we will move further. There is a system of unit. Now I will write the system of units. There are 4 systems of unit. There are 4 systems of unit. First is CGS. C stands for centimeter. This is gram and second. Okay, centimeter, gram, second. Then second is MKS. M stands for meter. K is kg and S is second. Then third is SI system, which is System International. It is accepted all over the world, System International. And fourth is FPS, which is foot pound and second. Okay, foot, pound, second. Foot is the unit of length, like meter is the unit of length and centimeter is unit of length. So foot is the unit of length. Then what are unit of mass? Gram, kg and pound and second. Okay, so these are all 4 physical system of units. Then after understanding the system of units, we will now do fundamental and derived quantities. So first we will do fundamental quantities. Now what are fundamental quantities? It is like example meter or second or degree C or kg, etc. So you can see that in this type of units of fundamental, these are all units of fundamental quantity. If you look carefully, you will see only one unit like M for length, meter, or second, degree C, kg. So there is only one unit and no other unit is with that one unit. So it does not require more than one units. Okay, so that are fundamental quantity. And next is derived quantity, which requires more than 1 unit. Second, derived quantity, which is derived quantities are dependent on one or more. For example, like kg per meter. Okay, kg per meter means 2 units. Then let's say Newton per meter square. There is also 2 units, Newton and meter, 2 units. Here also 2 units. Or we can take say centimeter per second. Okay, 2 units, centimeter per second or meter per second. This is the unit of speed. Okay, speed unit is meter per second. So in the unit of speed, which is meter per second, there are two units, meter and second. So this is derived, or Newton per meter square is the pressure. The formula of pressure is F upon A, where F is force, which is in Newton, and this is area meter square. So these all are derived quantities which have two or more than two units. So first we discussed about the definition of units, which is the standard measure of any physical quantity. Then the second we did was system of unit, which are CGS, MKS, SI and FPS. Then we just now did the fundamental and derived units. Next point is plane angle and solid angle. So first we will discuss plane angle. This is plane angle. Okay, so what is plane angle? If you draw circle, and this is center and this is radius, and this is ds, which is the length of arc, and this is d theta. So from figure, this is right angle because the angle is very small. So from figure you can see that sine of theta, d theta, means this is the d theta angle, is opposite, means ds upon hypotenuse is r. You can write r like this, r here, and this is your d theta. So sin d theta is opposite upon hypotenuse, so sin d theta is ds upon r. Then as the d theta is very small, sin d theta will be approximately d theta equal to ds upon r. So this is the formula of plane angle. Then we will see the formula of solid angle. So the second is solid angle. Solid angle. Solid angle. So we denote solid angle like this. This is solid angle. Now, if solid angle means what? This is the three-dimensional figure. For example, sphere. Sphere is three-dimensional. If I cut the area like this and separate from sphere, so this is your area A, and this is R, and this is solid angle. So this 3D angle, three-dimensional angle, is solid angle. D, it is denoted like this. D of, say, this is the ohm sign, but we call it a solid angle. And let me draw again the figure. So this is your area A, and this is solid angle, and this is R. So the formula of solid angle is, you can find out solid angle like this: R square into solid angle equal to area. This is the formula. Now what we will do, we will integrate both sides. What is the integration of this small area? Entire area. So I will write AT, total area. R is constant, and integration of solid angle is, d solid angle is total angle. Okay, so what is the area of sphere? Area of sphere is 4 pi r square. Okay, so r square cut, and total solid angle of a sphere is 4 pi, which we know. Okay, 4 pi means the total solid angle of any sphere. Now after this we will do parallax method, and this is the application of all this chapter, measurements and units chapter. So first application is parallax method. So I will write parallax method. So what is parallax method? In parallax method, we measure the distance of planet from any star, or means the distance between the earth and planet, or distance between earth and star. Okay, so that is parallax method. For example, this is your earth, this is earth, and let's say any 2 points A and B, and this is the star or planet. Then I will join like this. Now for parallax method, let's assume that this is D and this is you want to find out, because D is distance from earth to that planet or star. D. As you know, the star is very far away, so this angle must be very small. So I will write this angle at d theta. This distance say B. So we want to find out D. Again same sine formula, sine of angle, sine of d theta, which is opposite B upon hypotenuse D. This is approximately right angle because the distance is very far. This is small angle, so this must be 90 degrees. So this is right angle triangle, and sine of theta is opposite side upon hypotenuse. So sine of d theta is B by D. Now this angle is very small, so sine theta will be theta, which is B by D. Okay, so we want to find out D. D is the distance between Earth and that planet. So for finding out D, we will write D equal to B by d theta. Just we put d over here and d theta here. So this distance is distance between Earth and that planet or a star. Now the second is size. How can you determine the size of a star or any planet? For that, let's assume that this is that planet and this is d. This is the diameter of that planet, and it makes an angle, say alpha, on the Earth, okay, at this point. Then to find out D, means the size of that planet, let's do like this. Let's okay, so this is the 90 degree angle because the this angle is very small, so this is approximately right angle triangle. So I will write sine alpha equal to, opposite is D, and adjust, and hypotenuse is capital D, which is the distance between the two planets. So if I want to calculate small d, which is the diameter or size of the planet, I will write D equal to D sine alpha. I put D over here, the small d, D sine alpha. So this is the diameter of that planet D in terms of distance between Earth and that planet, and angle which the planet subtend at that point on the Earth.